Hi guys, hope you're all well. This is your awkward Indian linguist back again. So, I've been meaning to make a video for a while because I have some time on my hands. And yeah, firstly, hope you're enjoying the summer. It's like a lovely day here, and I'm sitting here in the garden as you can see. And hope you're all taking time out for yourself and recharging, which is really important, right? So, yeah, back to the topic of today's video. So this is again another trending topic, right? So like the notion of are language models intelligent? Do they have any sort of consciousness, and are they able to have sentience? So the word that was used was sentience, right? And so there is all of these notions that are being discussed, whether AI can become sentient, and whether language models can understand in the way understand the world in the way that humans do. So I just wanted to sort of like talk about one particular aspect, which is the notion of semantics. So when we talk about semantics, right, so there is, as a linguist, there is a notion of semantics that I'm familiar with, and then there is the notion of semantics as it's being used in like the NLP and AI literature, right? So I just wanted to sort of like compare these two approaches and compare these two notions of semantics and give you like a feel of the difference between the two, right? So let's go with like the language model notion of semantics first, right? So uh, many of you may be familiar with the term embedding. So like since 2013 there is this notion of like extracting the meaning of words. So you can characterize the meaning of a word as a real valued vector, and this allows you to sort of like to transform this into like a Euclidean space, and you can actually perform operations between words. So the famous example of king plus woman minus man is equal to queen, right? So that was the famous example that was cited by the word to vec paper. And since then we've had like different kinds of embeddings, different kinds of language models. So you have like transformer language models, and you have GPT, BERT, and all sorts of things. And now you even have like multimodal language models like DALE, right? So the main thing to note here is when they talk about semantics, what do they mean? So they say that you can capture the meaning of an expression or a word as like a vector of real valued numbers, right? So like let's take GPT or BERT. Like let's take BERT. So when you take BERT for a sentence, if you want to extract the meaning, so it comes up with like a vector of numbers, and the idea is that you can take that vector and you can feed into whatever downstream applications you are building, and this is going to sort of capture the meaning of the sentence. And let's say you have another sentence and you want to sort of compare the meaning of the two, then you can just extract the embeddings and calculate some sort of like distance metric between the two. So either Euclidean distance or cosine similarity or whatever you want to use, right? So what's what's the linguistic notion of similarity? What's the linguistic notion of like semantics, right? So in linguistics we have like semantics is like the study of meaning, right? And within semantics you have different aspects. So you have lexical semantics, which focuses on word meaning, and then you also have like phrasal semantics, so like things like compounds and phrases, like collocations. So they have as a separate sort of like semantics, where you can look at like the compounds in compounds, for example, right? Like the famous examples from Sanskrit grammar. So you have bahuvrihi compounds, and bahuvrihi compound is like when you have the meaning is actually not the combination. It's not strictly compositional, so you don't get the meaning. So let's say the yellow robed one, right? So the yellow robed one, the word is like Sanskrit was pitambar. So if you can't really compose the meaning from like the meanings of the morphemes, because it actually means something else. It refers to a person, and it doesn't really have like the compositional meaning. So yeah, so there is all these aspects of linguistic meaning. And then the most important thing is, when you talk about meaning of sentences in linguistics, we have the notion of compositionality, right? So compositionality is, you can take the meanings of like individual blocks, the building blocks, and then compose them using operations, semantic operations. So well known semantic operations. So I'll give you a quick example. So I wish like I had some slides, or I wrote down these lambda expressions. So yeah, all of you might be familiar with lambda calculus, right? So lambda calculus, so yeah, let's go back a little bit in history. So at the turn of the 20th century, logicians and like mathematicians, like most importantly Russell, there were many who worked on this topic, but Bertrand Russell is one of the most famous ones. So they came up with this notion of applying logic to describe like the semantics of natural language. So we have logic. So from the ancient Greeks, you have various studies of like formal logic, right? So you have things like De Morgan's law. So you can, so De Morgan's law, for example, negation of A union B is equal to negation of A intersection negation of B, right? So you have these logical expressions, and you have these kind of these you have these insights into logic. And how do you so let's take De Morgan's law. So how do you prove De Morgan's law? So if you remember your classes on logic, so you build like a truth table for the LHS, and you build a truth table for the RHS, and if the truth tables match, that's like that's a way of proving that the two logical expressions are equivalent, right? So Russell and also Tarski later. So Tarski is an American mathematician. So they came up with this notion that you can apply the exact same framework to characterize natural language. So if you have two natural language sentences, they mean the same thing if the truth conditions denoted by those sentences are identical, right? So that's the idea, basic idea. You can read more about it. I'm not going to go into all the details. And how do you arrive at the truth conditions? So you have so that's the lambda calculus part. So for example, if you have a sentence like John likes Mary, right? So then you have like the lexical entries for all these three words. So John is like a E-type entry, so it's an individual named John. Mary is also an E-type entry, which is an individual named Mary, right? And then like is actually a function which takes two arguments, both of which are E-type, right? And it's, so if I have to give you the lexical entry, it would be something like lambda x, lambda y, x likes y. That would be the lexical entry for like. And then you take the arguments, so Mary, so there'll be one functional application which will combine Mary with like, and then there'll be another functional application which will combine John with likes Mary, and that will give you like the logical expression. And then you take that logical expression and evaluate it with respect to the real world. In other words, you create that truth table, and so John likes Mary is true if in the real world the individual named John that you're talking about likes the individual named Mary, right? So then it'll be true, and if it's false, then it's false, right? So this is the linguistic notion of semantics, and you can see that the linguistic notion of semantics makes reference to the real world. So it's not just it's not just like language internal, right? So it's interfacing with the real world. But if you look at the language model sort of embeddings, right? If you let's set aside multimodal language models for now. Let's just talk about like text only language model. So text only language model has no interface with the real world. So you come up with like a sentence embedding, and those models are trained on tons and tons of web corpora, and those web corpora. So yeah, there is no notion of like referential semantics there. So what's the problem? So like two sentences can mean the same, even though like we don't know exactly what truth conditions they denote in the real world. So yeah, so there is an interesting um, in semantics, in classical semantics, Frege is like one of the most important figures in semantics. So Frege had this notion of sense and reference. So sense is like the meaning that an expression has by virtue of belonging to the language, and reference is what it refers to. So the most interesting example of this is like the morning star is the evening star. So yeah, note that like in this example the morning star is referring to Venus, and evening star is also referring to Venus, right? So Venus is known as both the morning star and the evening star. So if you look at reference, this sentence makes sense because that's true. Like it's just saying like a tautology, so Venus is Venus. But if you look at the sense, it's kind of like so what you're saying is the star that appears in the morning is the same star that appears in the evening. So there it's a bit more like it's a bit more like nuanced. So there you have to actually compute the denotation. So in other words, so the whole point of this example is that there is a difference between sense and reference. So reference is how the linguistic expression is being used to refer to the real world. So in other words, this is like the interface between language and world knowledge, right? And sense is purely in the linguistic domain, so it's in the language domain. So in the same way, so if you look at like the embeddings that you get from language models, those are text only language models, so they are only like in the linguistic domain, so they're only in the sense domain. They don't really have they're not talking about like the reference in the real world. And this is very different from the linguistic notion of semantics, where if two sentences are equivalent, just as two logical expressions are equivalent, so we have the same condition that the truth conditions should match. So the truth conditions should be the same for both sentences. The truth conditions are established with reference to the real world. So that's one thing that I wanted to sort of I've kind of written about this in posts, but I don't see this like being discussed as much. So they like there is some discussion about like compositionality. Another important thing about compositionality is so one thing that I want to quickly mention in the next 1 minute is so compositionality is actually structure dependent, right? So you there is a notion of like parsing. So for every sentence we sort of parse the sentence, we come up with a structure, and then we interpret that structure. So that's like the interface between syntax and semantics. So the semantic module basically interprets the trees that it gets from syntax. So so there can be many we can actually do a lot of interesting things by looking at like the syntactic parse tree, and then trying to interpret the parse tree using these operations. And also there is lexical semantics involved there, because like synonymy comes into play, right? So let's say John ate a sandwich, and John let's say ingested a sandwich. These two sentences are very different on the surface, but eat and ingest are synonyms. So you could end up with like the same truth conditions for both the sentences. So there is a role for like lexical semantics as well in compositional approaches to meaning, but that's kind of different. So and in the language model approach, they are combining everything. So they when two words mean the same and two sentences mean the same, it's the same sort of similarity for them. But in linguistics we have different notions. So when two words mean the same, it's lexical similarity, and two sentences mean the same, and lexical similarity doesn't have much to do with like the structure, right? So there is like word sense disambiguation, so there is ambiguity in language, so there is some structure dependence of word meaning, but it's not the same as like compositional sentence meaning, where it's interpreting the trees coming from syntax. Okay, so I don't want to make this more complex, but I hope this gives you some points to think about, and hopefully over the next few days I'll do a write up with a lot of examples in which I'll explain, my understanding of this. And yeah, like, I don't have any tenure, I'm not a professor, I don't know. This is all just based on my experience of learning linguistics and NLP. So take it or leave it. So yeah, I'm no authority. So it's all up to you. Okay, hope you have a nice time and enjoy the summer. Until next time, bye bye.